Welcome to You Can Do It Maths. We're doing the October-November 2021 paper 43. Let's have fun. Question 1a, describe fully this single, only one, transformation that maps triangle T onto triangle A. So get your tracing paper, ask for it in the exam. Here we go. All right. Now, first of all, let's look at what happens T to A. It's not a translation because it's not in the same orientation as B. It's not an enlargement because it doesn't change size. It's not a reflection because it's not symmetrical. So it can only be a rotation. So that's the first thing you write down. For 1 mark, you write rotation. Remember, we're going here for 3 marks. So we got 1 mark. Next, let's see how it turns. Okay. Pretty much that's clear. That's the center. And it turns clockwise 90 degrees. Okay, it's very clear. It's 90 degrees as well. If we connect the center with that right angle and that right angle, that's a 90-degree angle. So we'll write clockwise 90 degrees. That will give us a second mark. Yes, you can write anti-clockwise to 70. We don't complicate things. And the last thing for the third mark is the center of a rotation. As we can see, it's where I put the tip of my pencil, is this point here, which is the point 5, 2. Remember, along the corridor, up the stairs. So we write center 5, 2. Okay, make sure you write each one of those things correctly. Rotation 1 mark, clockwise 90 degrees 1 mark, center 5, 2, 1 mark. Okay, the next one, the transformation that takes single transformation like T onto B. Again, I say single because students in the exam, they confused and do one one. Right, this is clearly a translation. Very important that you get this word right. Don't write translocation. Don't write it moves. Okay, you need to write the word translation. Okay, get it right, study it. Yeah, remember now we're looking for 2 words, 2 marks, 2 marks. Okay, translation is 1 mark. Next one is the vector. Okay, remember what a vector is. A vector is not a fraction, it's in a bracket. We got a number at the top that tells us how much we move left or right, and at the bottom, the number tells us up or down. If we're going to the right, it's positive, to the left is negative, going up is positive, going down is negative. All right, so first of all, how much do we move up? For T, we move 1, 2, 3, 4, 4 squares. Let's do it. 1, 2, 3, 4. Yeah, 4 squares up. So the vector going up is 4 squares. And once we are there, we go 1 square to the left. Left is negative, so that is minus 1. Don't put a line in between. Don't write a coordinate. Okay, that's how you get full marks, exactly like that. 1 mark translation, 1 mark for the vector. Last one is a bit strange that they throw it in here with transformations, but okay, it is actually quite easy, but lots of students found this confusing. Calculate the distance that each point of triangle T moves when it is mapped onto triangle B. So meaning go from here. So this point here, for example, T, go to B, it moves like this. Okay, moves like that, right? The other points are going to move exactly the same distance because it's a transformation. So we only have to work out the distance of one of these points. Okay, let's do this point over here. So we want to know that exact distance. To know that, we can make a right angle triangle like this with a base of 1 and a height of 4, and then we use Pythagoras to calculate it. All right, so Pythagoras, as you know, let's call that distance x. As Pythagoras, you know, is the hypotenuse, in this case x squared equals the other two sides squared. So 1 squared plus 4 squared. On my calculator, we'll type the square root of 1 squared plus 4 squared. Okay, don't waste your time with this. 1 squared plus 4 squared, bam, square root 17, 4.123, etc. Rounded to three significant figures, 4.12, bam, you got your marks. Question 2a, look very carefully at this circle theorems. Yes, so first of all, AP is not a diameter, so we cannot use this theorem. Angle in a semicircle is 90 degrees, so APB, that is not 90 degrees. Okay, we're not going through the center of the circle. Now, whenever I get stuck with circle theorems, I look for one thing, and that is the radius of the circle. We have a radius there, OA, and a radius there, OB. The radius is always the same. It doesn't change, which means here we got in this triangle OAOB, we got an isosceles triangle. That means angle OAB equals 38 degrees. See that? That means we can get angle OAB. So AOB, angles in a triangle, which means there will be 180 minus 38 and 38, which is the other two angles, which is 104. Okay, next thing to look at is this circle theorem here. Angle at the center is twice the angle on the circumference. So if we look at that, this is 104, and we got these two lines here. Okay, this angle here, since it goes from A and B, is twice that angle there. So our next step would simply be 104 divided by 2 equals 52, and that's the answer. Question 2b, we got a cyclic quadrilateral. Remember, and a cyclic quadrilateral, opposite angles equals 180 degrees. We got the tangent. So look at any circle theorems that involves a tangent. All right, and we got that 50-degree angle. So first of all, okay, tangent theorems. This one, the angle between a radius and a tangent is 90 degrees. We don't have any radiuses here. We can't use that, but the one we can use is the alternate segment theorem. So if we look at that, for example, we got the triangle here and the tangent. Alternate segment theorem says that if this angle is 50 degrees, that one there is 50 degrees. Okay, then having these two sides the same means we have an isosceles triangle. The two base angles are the same. So to get EFC, we just need to do 180 minus 50 plus 50, which is 100. So that one is 80. Then for part 2, we got the cyclic quadrilateral. We got this angle here is 80. Opposite angles in a cyclic quadrilateral equals 180. So all we need to do now is do 180 minus 80, and we get 100. Surprising how many students got this wrong. You can do it. Question 3a, they give us a lot of information, and then they want us to find the mass of the prism. They tell us the volume is 525 centimeters cubed. 1 centimeter cubed is 7.8. So all we need to do is multiply that together. Which will give us 4,095. Be careful now, this was grams. And as you can see, they wanted a kilograms. So to convert it to kilograms, remember to convert from grams to kilograms. Kilo meaning 1,000. You just divide that by 1,000. And there we go. 4.095. Don't round this answer because it's already exact. Make sure your handwriting is clear. Then it tells us to calculate the length of the prism. Now, remember this. To find the volume of any prism, you need to take the area of the front face, in this case is a trapezium, times the length being that. Okay, so first of all, let's calculate the area of the front face. The area of a trapezium of a trapezium is half A plus B times the height. Okay, now what do we have here? A and B is the two parallel sides, so that will be 4 and 10. So that's 4 plus 10, and the height, they've given it to us back there, is 5. So that will be 7 times 5, 35 centimeter squared. So we got the area here, 35 centimeters square. To get the volume, we'll multiply that by the length. But now we're moving backwards. We got the volume, so all we need to do is divide it by 35 centimeters squared, and we'll have the length. So the volume was given there, 525 centimeters cubed. We divide that by 35 centimeters square, and that, of course, will give us the answer in centimeters like they want. So it's important to take note of the units. Right, part 3, calculate the total surface area of the prism. So a lot of scrolling back and forth we're going to do here. Now, first of all, we already had the surface area of the front and the back. So let's write that down. So the front and the back is the same. It's both 35. So the total there will be 70 centimeters square. All right, let's next do the top. The top face is this one over here. We have 4, and we worked out the length just now, which was 15. So remember, the length is 15 centimeters. So that will be 4 times 15, which will give us 60 centimeters squared. Now let's do the bottom, the base. So for the base, we have 10 centimeter width and the length 15. So all we need to do there is 10 times 15. Then we got the left and the right side. Let's just say the sides. Okay. And they're going to be the same. So we can work out one and double it. So let's see what we have here. For the sides, we have the length, but we don't have the height or the width in this case. Okay, what we do have is we can make a triangle here, a right angle triangle with a height of 5. And the base then, let's think very carefully about the base. That is 4. Then I need to split up these two sides to the remaining, which will be 6. So this needs to be 3. So we got 3 plus 4 plus 3 equals 10. So I got a triangle with a height of 5 and a base of 3. And right angle triangles, to find the hypotenuse, yes, we use Pythagoras. So I'm going to call this BD. All right, so we're going to do that. BD squared equals 5 squared plus 3 squared. So BD, which is the height of our rectangle, the width, is the square root of 5 squared plus 3 squared. Let's do that. Okay, now it's most accurate to keep our answer in third form, which is this form. Okay, we can write 5 point whatever. Square root 34 is more accurate. Sorry, to find the area of the two sides now, we are going to do, we know this length now, it's square root 34. So square root 34 times 15 times 2, because the other side is there as well, and it's got the same area. And we do that on the calculator. Let's still leave it in third form. Now we can add together our sides, 70, 60, 150, and that one. Still have that on my calculator, so I just add the 150, add the 60, add the 70, and bam. Okay, let's call that total surface area. Helps it looks like an L. 454.928. And now we can round it to three significant figures. 455 centimeters squared. Show all your working. 6 marks is a lot, so they want to see everything. Okay, don't leave anything out. You get full marks. Question 3a, part 4. It says here, in a mathematically similar prism, you've got the same prism, the height of the trapezium is 10 centimeters. Okay, if you remember, the height of the trapezium we just had was 5 centimeters. So if we divide 10 by 5, it means that trapezium is twice as big. It says calculate the volume. Now, similar shapes is all about ratio. So if 10 over 5 centimeters gives us the ratio of the big one over the small one, we do the same here. We got the small one at the bottom, and they gave us, remember, the volume of that one was 525 centimeters cubed. Okay, and they gave it to us up there, just in case you forgot. There it is. Okay, and we want to know the volume of the new bigger one. It's important to write it like this because we can now notice a few things. All right, first of all, we got the bigger shape written over the smaller shape, both in the volume and the linear scale factor. And second thing is the scale factor. The volume is in centimeters cubed, and the other one is linear, it's just in centimeters. So to get the scale factors correct, the same, we need to cube the scale factor. So in the end, the calculation we will do to find that is 525 times 10 over 5, or just 2, cubed. So on the calculator, 525 times 2 cubed gives us the volume of the bigger prism. Very good. Question 3b. The moment you see correct to the nearest, you know you are using bounds. That measurements 10, 4, and 6 centimeters. Those values has been rounded. So the very first thing you do is you take to the nearest, in this case 1 centimeter. You take 1, you divide it by 2, you get 0.5. And that we need to add and subtract from the values they've given us before we do anything else. Okay, so meaning for 10, we need to get the lower bound and the upper bound. The lower bound will be 10 minus 0.5, which is 9.5, and the upper bound 10.5. Okay, and that will be the same for all the other ones. So the 4, the lower bound will be 3.5, the upper bound 4.5. And the last one, 6, lower bound 5.5, upper bound 6.5. Okay, before you do any calculation, you work out the bounds. All right, now they're talking about the volume, so that's easy. For a cuboid volume, you multiply them together. So for the lower bound, we multiply together the lower bound value. So 9.5 times 3.5 times 5.5. Okay, 9.5 times 3.5 times 5.5. Okay, and it gives us 182.875. Okay, now very important, very, very important here. That isn't an exact answer because it stops at 5. Also, we're working with bounds here, so they want to know what was it before things got rounded. So if we round back again, it's counterproductive. So don't round these answers when it comes to bounds. For the upper bound, we need to multiply the upper values, 10.5 times 4.5 times 6.5. And there we go, 307.125. Don't round that. It's an exact value, and we're working with bounds. They want to know the answer before we rounded it, and then you've got it. Question 4a, simultaneous equations, and they've lined everything up for us nicely, the equal signs, the q's, the p's. So of course the quickest method here would be the elimination method, right? Now we need to get either the q's or the p's the same. We can multiply the top one by 3 and the bottom one by 2 to get both the top and the bottom 6p, but quicker would be just to multiply the top one by 2. So that will give us 4p minus 2q equals 14. I'm just going to write again the second equation underneath. 3p plus 2q equals 7. Right, next step would be to add or subtract them together. Right, so if we were to subtract them, we get 4p minus 3p is p. That will work, but minus 2q minus plus 2q, plus and a minus is a minus, that will give us negative 4q, and that's not what we want. We want to eliminate the q value. Okay, so subtracting is not going to work. We need to add them together. So that will be 4p plus 3p is 7p minus 2q minus 2q plus 2q in the end basically will be 0, and that means we've eliminated the q value, and that's what we want. 14 plus 7 is 21. So the next step will be to divide the 7, and we have the p is 3. Brilliant. Now to find q, we substitute it back into any of the equations at the top. You can do the first or the second. Let me do the first one. So 2p, oh no, we want to change the p for a 3, minus q equals 7. That gives me 6 minus q equals 7. That gives me minus q. 7 minus 6 is 1. Divide the 1. Okay, so minus q equals 1, so q equals minus 1. And we got the answer. You can quickly check your answer. Let's check that. Take that second equation. Okay, this doesn't count marks, but it helps to give you peace of mind. Right, let's take that second equation, and we write, substitute the values. We had p as 3, and we had q as minus 1. So 3 bracket 3 plus 2 negative 1 gives us 7. So 7 equals 7. It's correct. We know we got the right answer. Question 4b. First, we need to add these two fractions together. Now remember, if it was basic fractions, let's say it was a quarter plus 2 over 3. There's a smiley face method where we get the same denominator by multiplying the 4 and 3 together, and then multiplying across to make sure we got equivalent fractions. So 3 times 1 is 3, 4 times 2 is 8, and that will give us the right answer. Okay, now in this case, we just have a few x's in there, but we do the same thing. So first thing we do, we multiply the 4 and the 3 together. That gives us 12. Multiply the 3 with an x, so that gives us 3x, and multiply the 4 with a 2x, that gives us 8x. Okay, and that's equal to 1. Right, now we can simplify the x's. 3x plus 8x gives me 11x, and we can multiply the 12 on the other side. 12 times what is 12? So the last step is to divide the 12 by 11, and that gives you the answer, 12 over 11. Now it doesn't say write it as a mixed fraction or improper fraction or a decimal, so you can write any of those. You can write 1 and 1 over 11, 12 over x, or I see even on the math key 1.09 would also work. Question 4c, solve the inequality. Okay, so what to remember is here that we got two signs. It's like two equations in one. Okay, so my favorite method is to remember that what we want just an x in the middle and then the two answers on the sides. The first thing I'm going to do, I'm going to add 2, and like any good equation or inequality in this case, we need to do the same everywhere. So we need to add a 2 there and add a 2 on this side. So that will give us minus 6 is less than 3x is less than or equal to 9. Next step is to get rid of that 3. So we divide by 3. We do that on both of the other sides. Okay, 9 divided by 3 is 3. 3 divided by 3 will cancel. We're left with the x like we wanted. And minus 6 divided by 3 gives me minus 2. Part 2 then, find the integer values of x that satisfy the inequality. So first of all, minus 2, x cannot be minus 2 because there's no line underneath the sign. Okay, so x is bigger than anything minus 2. So that my integers means whole numbers. So that's minus 1, 0, 1, 2. And then of course, because we have that line, it includes the 3. Right, question 4D. Factorize completely. That's the word, completely. So first of all, we see the common factor of 16 and 4 is 4. And the common factor of a and a squared is a. What is left then? We need to have a 4, because 4a times 4 is 16a. And we need an a minus a, because 4a times minus a is 4a squared. Okay. Now there is other answers, but that will only give you 1 mark. Okay, so if you write, for example, 4, and we got 4a minus a squared, only 1 mark. Or if you write a, 16 minus 4a, 1 mark. Completely means you have to factorize both the 4 and the a. Question 4e, part 1. When we divide with fractions, we do the invert, which means we swap the second fraction around and multiply. Right, so that will give me 4b over 6a as we multiply the top with the top and the bottom with the bottom. And then we can simplify it, because we want it in a simplified by dividing both by 2, which will give us 2b over 3a. Of course, we could have, before we multiplied, we could have simplified it, and then we could have gotten 2b over 3a straightforward. Question 4e, part 2. I think the most important thing to remember here is that we can rewrite that 2 as a fraction, 2 over 1. The next step would be to get the denominators the same, which means we multiply the denominators together, which will of course give us x minus 1. Then we multiply across there to get equivalent fractions, so we need to multiply 2 by everything, x minus 1. And we multiply across here, 1 times minus x is minus x. Okay, this is exactly similar to question, what was it, 4b. So if you get confused, look at what we did at 4b. Same technique. Now we can expand the bracket. 2 times x is 2x. 2 times minus 1 is minus 2 minus x over x minus 1. We can subtract that x from the 2x, which will give us x minus 2 over x minus 1, which is our final answer. Write it on the line, and you've got it. First of all, very important to remember the formulas for simple interest and compound interest. Simple interest, you get the interest. Remember, interest is just the extra amount of money that you earn when you invest something, or that you pay if you have a loan. Only the extra part is the principal, P, principal meaning the original amount you start off with, times R, which is the rate, 3%, times time over 100. Compare that to compound interest, you get the total amount. So that's how much you have in the bank in total, or how much you owe somebody in total. Is again P, the principal, the 500 you start off with, 1 plus R, the rate, 3%, over 100 to the power of, they said n using the formula, you could write T, n, whatever, this is the time. Okay, so for the first one here, for simple interest paid, we need to take the principal, which is 500, times the rate, which is 3, times the time, which is 7, and divided by 100. So bang that in, 500 times 3 times 7 divided by 100, you get $105. And that's it. That is 100. That's it. Because this formula gives you the interest. With the compound interest here, we need to be careful though. Let's first use the formula 5. The principal again was 500. We started off with 1 plus the rate was 3 to the power of 7 for 7 years. So let's put that in. 500, 1 plus fraction button, 3 over 100, arrow, bracket to the power of 7 equal. Okay, let's write that down. 614.936, etc. Now be careful here, right? Compound interest is better than simple interest, but it's not that great that you will have, instead of 105, 614, because again, this is the total amount you'll have in the bank. That's the difference. So to get just the interest, just the extra amount, you need to take this amount and you subtract the original amount, which was 500, to get just the interest. Okay, which is 114.936, etc. And now we can round it to 2 decimal places, since this is money. All right, although I see on the mark scheme they do mark correct 115. Well, they would mark that correct as well, 100. If you round it to 3 significant figures, yes, because it's not exact. That's true. Either way, I will get my marks and you'll get your marks. If you write 115, both get you the marks. But remember to subtract. Remember, this is the biggest thing, the difference between compound and simple interest and what the formulas give you. Question 5b, decreasing exponentially means we use basically the same formula as for compound interest. To get the amount of something, we take the principal, and because it's decreasing though, instead of adding, we'll subtract the rate divided by 100 to the power of time. Okay, let's put the numbers into that formula we have. Now, calculate value of the car 3 years ago. That's the principal, that's the P, that is what it was when they started, when they bought the car. Okay, and that we don't have, so let's leave it as P. We have the rate is 10%. We have the time, which is 3, and we have the amount that the car is value now, right? It's 6269.40. So that's what we need to work out. Okay, now remember, this is the principal multiplied by that whole bracket. So if we can just take this whole bracket and do the opposite of multiply, and that is divide. So get P, we'll take 6269.4 divided by all of this. So let's do that. 6269.4 divided by, use the bracket to be safe, put it in exactly like that, bracket cube equal, get a beautiful number there, 8,600. Sounds like an amount people would sell a car for. Okay, and that is the correct answer. Question 6, we see triangles, we think trigonometry. Okay, right angle triangles, you work with the sides, you do Pythagoras. You work with the sides and the angles, you do SOHCAHTOA. Any other triangle that's not a right angle triangle, you're either going to use the sine or the cosine rule. So let's have a look here. Calculate AD. AD is this length. It's inside this triangle. We know we need to use the cosine or the sine rule. Now, what I look for always first is opposite angles and sides. And once you have that, if you got angle and the opposite side, you know you're going to use the sine rule because that's what the sine rule is about. And then we can use this opposite angle to get AD. We start off by writing down the side we want. Always put it at the top of the sine rule because the sine rule has two versions. In our version, we want the side on the top. So that's AD over sine 50 equals, we put the sides at the top, so that will be 12 centimeters over sine 100. Writing it like this makes it easy because now to calculate AD, we can simply multiply the sin 50 on the other side. We multiply with a 12 and we divide it by sin 100. So let's do that. You can do it the other way around. 12 times sin 50 over sin 100. Bam. And we get 9.334, etc. Rounded to three significant figures, 9.33. Next one is question 6b. Remember what we said, right angles is Pythagoras and SOHCAHTOA, everything else is sine and cosine. We just used the sine rule, so you probably think we need to use the cosine rule, but let's have a look anyway, right? So they want us to get angle BAC. There we go, so that is that angle there, and we don't have any angles. Okay, so that means, yes, we're going to use the cosine rule, and we're going to use the rearranged version of the cosine rule. Let's remind ourselves of the cosine rule. The cosine rule starts with a squared equals b squared plus c squared. Pythagoras helps us to remember it. Minus 2bc, remember that part. And then it's the cosine rule and a. Now that is very useful if we want to work out a side, which is lowercase a. But if not, we want to use the rearranged version. We want to find the angle, we do cos A equals, and then it's that part again, b squared plus c squared, but the a squared moved over, so it's minus a squared over, we have this other version, the remainder, but it's positive, 2bc at the bottom. Okay, now before I even start, I want to do some more rearranging. So we want to find angle A. To find that, we're going to have to move the cos as well. So that's cos minus 1. And then the rest of what we got there, b squared and c squared. Now it's nice here, they've already we got a, b's, and c's, and they're all in the right place. So if that's capital A, this is little a, that's capital B, this is little b, and that's lowercase c. Okay, so we start with b squared will be 12 squared plus c squared is 11 squared. By the way, it doesn't matter if you swap these two around. What's important is that you get this side that is opposite the angle, that's the 8 squared. Okay, make sure you write nicely. Over to 12 and 11. Now we can put that into our calculator exactly like that. So we start with shift cos bracket fraction 12 squared plus 11 squared minus 8 squared over 2 times 12 times 11. Close the bracket. Now this is very important. We write the unrounded answer. Okay, at least to 4 significant figures. Okay, and even though they gave us the answer there, and we're very happy now because if we round our answer, we know we got it right. You need to show that it rounds to that, which means you need to write the unrounded answer. That counts a mark. Many students lose a mark because they don't write this. Okay, so this is essential to get full marks. Okay, then it tells us question 6c, to calculate the area of the quadrilateral, the whole shape. Okay, so remember, there's a formula for the area of a triangle, which is half base times height. In this case, if you don't have the perpendicular height, you do half A, B, sin C. So that's what we want to do. So let's label this. I'm going to make this triangle 1. Okay. What do we have in triangle 1? We just worked out our angle, 40.42. That's what they gave us as well. Let's write that down. Okay. And we are going to use that information to work out the area of triangle A. So, area triangle 1 is half. Now, what is AB and what is sin C? Okay, sin C is the angle. So, in this case, now we're going to change that A to a C. All right, that makes the other two sides A and B in any order, A and B or the other way around. Okay, so don't let the A, B, and C in that triangle confuse you. You might change it to what you want it to be. So in this case, it will be a half. A could either be 12 or 11. Let's make it 12. Of course, B is already 11. Sin C is that angle they've given us. Okay, let's type that in. A half, 0.5, 12 times 11, sin 40.42. Okay, that gives me 42.793. Don't round it yet. Put a nice bunch of decimals in there. Okay, now we're doing the area of triangle 2. So we're going to start with a half. Let's see what we have there. Start fresh. A, B, sin C. So sin C could be either this angle here or the angle there. But we need the two sides next to the angle. Okay, what do we have? We got AD. AD is 9.33. Okay, so A and B in this case needs to be two sides we have. So we're going to make this little A and this little B in this equation here. And we need that angle there. That's easy to get, thankfully, because we know 180 minus 100 plus 50 angles in a triangle. That must be 30. And that will be the angle C we use. So again, we made this C and the other two is A and B. So it will be a half, 9.33 and 12. Sin C, which was 30. Let's do that. $27.99. Adding together the two triangles. Okay, leave this answer here. Add to it my previous answer. Oh no, that's not going to work. Let's type it in. 42.7934. That's enough to get an accurate answer of 70.78, etc. Rounded to three significant figures, 70.8, which is correct. You've done it. Well done. Question 6D, calculate the shortest distance from B to AC. So, let's clear the clutter. The shortest distance from B to AC. And that would be, of course, a perpendicular line. Right. So, the shortest distance, we want this distance, let's call it X. That gives us a right angle triangle. So, bam, we can use Pythagoras or SOHCAHTOA. Can we use Pythagoras? Well, we got the hypotenuse. Okay, but we don't have the base of the triangle. It's not 12. AC is 12. And remember, we had another angle, the angle BAC. They gave it to us there, 40.42. Okay, and so when we are working in a right angle triangle and we got angles involved, we can use SOHCAHTOA. So let's do that. Let me change colors here. Right, so we have 11 is the hypotenuse. It's opposite the 90-degree angle. We got this angle here. And what we want to know is the opposite side to the angle. So the O and the H means we're going to use the ratio. So let's write that down. Okay, so it's always sin, then the angle, which was 40.42, equals, O is first, so the opposite is first. We labeled it X, over the hypotenuse, which we saw was 11. So to work out X, we just need to multiply the 11 there. So it's 11 times sin 40.42. Let's go for it. And we get X equals 7.1322, etc. Rounded to three significant figures, 7.13. Well done. Question 7a. Amir buys 3 cakes that cost C cents. So the total cost of that will be 3 times C, or just 3C. And 2 loaves of bread, which would be 2 times the cost of the bread, which is 2C minus 11. And that gives him a total of $5.87 if we add it together. Okay. Next thing is to expand those brackets. 3C, 2 times 2C is 4C minus 22 equals 587. Okay. Add together the C's, that give us 7C minus 22. We need to be very careful here now because something is wrong. Because the next thing I need to do 5.87 plus 22. Okay. Well, what is this? This is cents, because it says cents there, and this is dollars, this is in dollars. So remember to change your dollars to cents, which means we just multiply by 100. Okay, now that makes more sense because that gives us 7C equals, what's that, 600, 500, 609 cents. So C is 609 cents divided by 7, which gives us 87 cents. Okay, which makes sense. 87 cents. Right. Question 7b. A bottle of water costs W. Make up a number if this is confusing. Let's say a bottle of water costs $10. Sometimes having a number there is easier. A bottle of juice costs 10 plus 1 is $11. Alex spent $22 on bottles of water. Okay, it's very expensive water that I've chosen. But anyway, how would we figure out how many bottles he bought? We would divide, of course. We would divide it. We'll take how much he paid divided by how much it cost, and then we'll know how many bottles of water he bought. Just instead of dividing by 10, we're going to divide it by W. Okay, and it's the same for the juice. He spent 42. If we divide it by how much it cost by 11, we'll get how many bottles he's bought. But it's not 11, it's W plus 1. Okay, then they tell us they are equal, so we can set that to equal. All right, so to solve this, we need to first get rid of the fractions. I'm going to multiply this over there. That will be 22. Multiply that over there, 42W. Expand the brackets. Then I'm going to leave the 22 here. I'm going to subtract the 22W on the other side. That gives us 22 equals, what is 42 divided minus 22, of course, is 20. And then divided So 22 divided by 20. W equals 1.1. We've done it. Well done. Question 7c. The moment we see distance, speed, time, you need your little triangle. Okay, remember that. Remember driving down the highway. You're going 120, that's the speed. Kilometers, that's the distance. Per hour, that's the time. Okay, HDT. Now they're talking about the total time Alicia takes. So that is the total time. So for the first leg, to work out the time, we take the distance, which is 9, divided by the speed, which is x. To that, we need to add the next leg of the journey. Again, that's the distance, which is 5, divided by the time, which is 2x plus 1. And that gives us a total of 2.5. Now again, this is adding algebraic fractions. Third time in this paper, we need to remember how to do this. Look at previous questions. Okay, so we do the smiley face method. We multiply these two together, so that will give us x over 2x plus 1 to give us the common denominator. Multiply that over there to keep the equivalent fractions. So that's 9, 2x plus 1. And multiply the x there, that is 5x. Right, let's expand all the brackets just because we can. So 9 times 2x is 18x. 9 times 1 is 9. Got a plus 5x hanging around, don't lose it. And at the bottom, x times 2x is 2x squared. And x times 1 is x. Right, at the numerator there, we can add the 18x and the 5x. That gives us 23x plus 9. And we can multiply this on the other side. So that gives us 2.5 times 2x squared plus x. So let's expand that bracket. 2.5 times 2x gives us 5x squared. And 2.5 times x gives us 2.5x. Right, I want everything equal to 0. So what I'm going to do, I'm going to put the 0 on the left side, which means I got the 2.5x. I move the 23x to the other side, so that's minus 23x. And we move the 9, so that's minus 9. That will give us 5x squared. 2.5 minus 23. A nice minus 20.5 x minus 9. Let's look now. If you notice, everything there is double, so we just multiply this by 2. And we can chuck the 0 to the back. 5x squared times 2 is 10x squared. Minus 20.5 times 2 is 41x. And 9 times 2 is 18. And we've done it. Well done. Then it says work out her running speed. You must show your working. So we're going to use that equation that they've given us. So meaning if you got the previous question wrong, you can still do this one. Right. There are different ways of doing this. Let's have a look. We can try to factorize it. And if you're familiar with factorizing questions like these, go for it with all means. But maybe the quickest here would be using the quadratic formula, since they didn't say how we must do it. So remember, the quadratic formula, x equals negative b plus minus b squared minus 4ac over 2a. So first of all, in our equation here, a equals 10, b equals minus 41, and c equals negative 18. So be very careful with those negatives. Best thing to do is use brackets. They are very safe. So let's start with the formula. There's negative, b is negative 41, plus minus square root, in brackets, negative 41 squared, minus 4a is 10, and c is negative 18, over 2a is 10. Okay, remember now we're going to get two answers here. So let's go for it. Fraction, negative, bracket, negative 41. Let's start with the plus, square root, bracket 41, close bracket, square. Actually, if you leave the negative out here, it will work because squaring a negative gives you a positive. If you do put the negative, make sure you put it inside the bracket and you put the square outside the bracket. Minus 4, oh, careful there, use the arrow, minus 4, then we got 10, negative 18, that negative is important, don't lose it, 2 and 10, and we press equal, and we get 4.5. Now we can just go back and change that plus for a minus and get our other answer, negative 0.4. Right, so the question is, work out Alicia's running speed. What is x? Now, a walking speed is x, so running speed is 2x plus 1. So we need to substitute it into that. So 2x is 4.5 plus 1. That will give us 10 kilometers per hour. It's very important to read what the actual question is very carefully because you lose that last mark if you're not careful. Right, I'm back to question C, 7C part 2. And if you did not use the quadratic formula to solve this equation, but you wanted to use factorization and want to see how that is done, you can. All right. Remember now, this is the A value, this is the B, this is the C. If you want to factorize it, we start by multiplying the A and the C values together. So that is 10 times minus 18, which is minus 180. We're now going to look for two factors of minus 180. When we add them together, we get the middle term, minus 41. So let's think about that. Let's do minus 20 times 9. That gives a minus 180. But when we add them together, we get minus 11. Okay, so that would not work. We need to try something else. Let's go for maybe minus 30 times 6, is it? Yeah, when we add them together, we get minus 24. No. Let's see, what else is there? 45. Yes. 180 divided by 45 is 4. So minus 45 times 4. And when we add that together, we get minus 41. And there we go. Those are two factors. Okay, so our next step would be to rewrite that equation and split the middle term into that. So we got 10x squared minus 45x plus 4x, because those two together will give me minus 41x minus 18. What we can do now, let's bring some color in here. We can factorize this bracket and factorize that bracket. So let's do that. First bracket here, common factor of 10 and 45 would be 5. And then the x as well. So that will leave us with 2x minus 9. Because 5x times 2x is 10x squared. 5x is minus 9 is 45x. Factorizing the second bracket, common factor there is 2, which will leave us with 2x minus 9. Brilliant, because that is the same. We can factorize out the 2x minus 9 and put in the other bracket 5x plus 2. Don't forget the x. 5x plus 2. And you factorize it. Excellent. Now we just need to solve it. We put 2x minus 9 equal to 0. That means 2x equals 9. That means x equals 9 over 2, which we got in the previous answer. And 5x plus 2 equals 0 gives us 5x equals negative 2, which gives us negative 2 divided by 5. And then you have the two answers, 4.5 and negative 0.4. Okay, just to finish it off, remember To get the running speed, we need to use this 2x plus 1. So you are going to do 2 times 4.5 plus 1 equals 10. For your final answer. Well done. Question 8. And G has been asking 600 people, going around asking lots of people, lots of stuff, their favorite sport. The pie chart shows the information. Show that 100 people choose tennis. All right, so what do we know about tennis? We know tennis has got an angle of 60 degrees. And we know that a whole pie chart is a 360 degrees, so that's a fraction. And we want to know what that fraction is of the total 600. And that's it. That's all you need to do. Slot that into your calculator to check if you've got it right. 60 divided by 360 times 600. Bam. Okay, what's important here is the calculation. Of course, that's what you get the marks for. Next one, work out how many people choose rugby. So what do we know about rugby? It's got an angle of 27 degrees out of 360. That's the fraction in the pie chart. We want to know what fraction of 600 that is. So it's the same calculation. All right, so in fact, we can just change that 60 for a 27. Bam, 45. Right, next one says 125 people choose cricket and the rest choose swimming. Complete the pie chart to show this information. So we first need to do this calculation. Again, pie chart is just about fractions. So for cricket, 125 people out of, how many is the total? 600. We want to know what that fraction is, and the pie chart, a fraction of 360 degrees. Okay, so we do 125 divided by 600 times 360. 75 degrees is what we're looking for here. Okay, so we need to put 75 degrees in the pie chart. Now, very important to do these things right. We are gonna go, you can go from the top or the bottom, doesn't matter. I'm gonna go from the top. So make sure you have the middle of the protractor in the middle of the pie chart, of course. Make sure you got a 0 on the line. So make sure it's perfect, yeah, be very accurate. Now, since we have the bottom 0 on the line, we're going to use the inside numbers. Okay, if we were doing it down here, for example, from this way around, okay, we have the outside 0 on the line, so then we use the outside numbers. Anyway, I want to use the top one. So there we go, we got a 0 on the line. 75 is what we're going for. The 75 would be between there, so make a little mark. Okay, and then very important, use a ruler, use a pencil. This is what gets you full marks. And there we go. Okay, and then we need to write in what we know. 75 degrees, those were the people that chose cricket, write that in. And the rest choose swimming, so we put swimming in there. Okay, I mean, the pie chart is complete. We can work out the angle for swimming, but I think there's going to be a little bit waste of time at this stage. We got what we need to get full marks. Question 8b. The heights of some plants are measured. Let's get it right. And we need to draw a box and whisker plot. Okay, again, ruler and pencil. In the examiner's report, they specifically mentioned that participants who did not use a ruler and pencil made mistakes and did not gain full mark. So the smallest height 0.6. So let's just count the scale very carefully. There's 5 squares between 0 and 1. So each square counts for 0.2. So that's 0.2, 0.4, 0.6. So at 0.6, draw a nice line. The length is 9 point. You can make a dot as well. That is the smallest height. Right. Let's draw what we can. Then the lower quartile is at 3.4. 3, 2, 3.4 there. That's the lower quartile. We can connect that with the line. Interquartile range. Okay, let's do the interquartile from 3.4. So from 3.24 to get the upper quartile, we need to take the lower quartile and add the range. So that would be 5.5. No, 7.5, of course. 7.5 makes more sense. So that's right in the middle between 7 and 8. Okay, be very exact. So we got the lower quartile, the upper quartile. Now we can do the median. Is at 5.2. We can now complete our little box for the middle 50%. Okay. We use the interquartile range. So the range will be from the lowest value to the highest value. So we take that 0.6, add 8.1, that gives us 8.7. Okay, so 8.7, 2, 4, 6, 7, right there in between. Ruler and pencil. If you make mistakes, you can rub it out and be as accurate as possible. And we've done it. Question 8C. The frequency table shows us some results of a dice that was rolled 100 times. Now we need to understand exactly what this table means. Okay, it means if we line up all the rolls, all the dice. Imagine we got 100 dice and they all got a number on it. First we'll have 16 dice that's got a 1 on it. 16, imagine them in a row. Each dice is on a 1. Then we have 24 with 5 dice lined up and they each got the 2 on top. And then 17 with the 3. And at the far end we'll have 15 dice lined up and they all got the 6 is the top number. So when we're asking for the range, we're looking at the dice with the biggest number, the one at the far end. Okay, that will have a 6 on it. And the first dice in the whole row. The first dice will have a 1 on it. Okay, so that means the range of the scores we got was 5. Okay, it's not the highest frequency minus the lowest frequency, which is what most students wrote. The mode is which dice is there the most of, which number is at the top the most. And that would be, of course, 2, because there are 25 dice with the number 2 at the top. So the mode, the most common, is 2. Okay. Then Cheetah's at it again, barking. The median, not the mean, the median is the middle numbers. Remember now we got 100 dice lined up. On the one side we got the ones with the 1, on the other side the ones with the 6. What number is in the dice in the middle? So doing this mathematically, we take 100 and we don't just divide it by 2, we need to add 1 and divide it by 2. That will get us the exact middle. So 101 divided by 2 is 50.5. That means the middle of this row of dice is between the 50th and the 51st dice, because then we'll have 50 dice on the left and 50 dice on the right. So let's start here. First we got 16 dice lined up. They all got a 1. Then there's another 25 dice, all with a 2 on it. So 16 plus 21 is 41. Then there's another 17 dice with a 3 on it. That will give us 58. So where is the 50th and the 51st dice? It will be in this group of between two of these 17 dice here. And what do they have on them? A 3. So the 50th dice will have a 3, the 51st dice will have a 3. We take the average of 3, which is 3. It's not that hard if you understand what it's all about. Question 8D. Now we got 50 students who answered a mathematics question, and the time shows how long it took for them to complete it. Again, when you understand what the table shows, 2 students, they were the quickest, took between 10 and 20 seconds to finish this question, and at the far end there were 12 students who took between 50 and 80 minutes to finish it. This time it's the mean. Mean means we add it all up and divide how many there is. So what is everything we need to add up? It's all the times of every student. Okay, it's an estimate because we don't know their exact times. So these first 2 students, we don't know exactly how long they took. We know somewhere between 10 and 20. So we take the average of that, or the midpoint, 15 seconds. So we estimate that on average they took about 15 seconds. So if we add their times together, we have 30 seconds. To that, we need to take the next 8 students, have an estimate of how long they took, and the midpoint there is 22.5, between 20 and 25. So we need to add up all their times or multiply it together, and we continue with this pattern. So it'll be 12 times 27.5, 16 times 40, 12 times 65. If at any point you're not sure what is the midpoint, add the 2 numbers together. For example, here, to find the midpoint here, we do 50 plus 80 divided, divided by 2, which of course is 65. That will give us all the times added together, all the students. Okay, so if we make one student after the other do the question, how long will it take them to all do the questions? All right. Then we divide it by how many there is. Okay, we can add up all the frequencies or just read the question. It tells us there's 50 students. And then we hammer it into the calculator. Let's get the calculator and we put it in there. Fraction. Take your time because there's a lot of mistakes that can be made. Divided by 50. And I get 39.2. Look carefully. Where is 39.2? 39.2 is over here. It is round about the middle because the numbers on the right is a bit bigger than the numbers on the left. It's a sensible answer. It makes sense. If I got something closer to 20, 10 or lower, or above 50 to 80, then I know it probably is wrong. I've typed something in wrong somewhere. 39.2 though is absolutely correct. Question 9. Look carefully. Find the coordinates of the points where the graph of y equals fx function of x crosses the x-axis. All right. What happens where we cross the x-axis? Okay. Y equals 0. Also, if we look at the next question, we can see that we got the same function fx, and we got a cubic equation there. Okay, which means if we multiply out these brackets, we should get what's down there. So it's a cubic graph. You know what a cubic graph looks like? Let me show you. All right, so where does it go? There's the cubic graph. I've slotted it in on the left, and there you can see there's the graph. Also on this graph, you can see where it crosses the x-axis. You see that? There's the 3 points. 0, 0, 1, 0, 2, 0. That, by the way, that's the answer to this question. Okay, and as you can see, the y value is always 0. The x value changes 0, 1, 2, but the y value is 0, 0, 0. So that is what we need to do in this question. Okay, where we cross the x-axis, y equals 0. So we take our equation here and set it equal to 0. Okay, and if you remember, solving equations like this, we can set each part, because being multiplied together, equal to 0. And we have three answers here. So the first one, x equals 0, we have the first answer. Second one, x minus 1 equals 0, that means x equals 1. Got the next x coordinate, and then of course x minus 2 equals 0, that means x equals 2. Now what's left to do is to find the y-intercept. Okay, now function of x up here, we can make that as y as well. So all we need to do is substitute into that equation at the top the x value. The first one will be 0, 0 minus 1, 0 minus 2. Okay, long story short, minus 1 times minus 2 is 2, but that gets multiplied by 0. Anything times 0 is 0. So that was the first point we saw, right? Next one, to get the y value, we do 1, 1 minus 1, 1 minus 2. Okay, what's that going to give us? You know, 1 minus 1 is 0. 1 minus 2 is minus 1. And that gives us 0 as well. And the last one, we get y2. Oh, I'm running out of space here, am I not? Let's do it over here. Okay, last one, y2, 2 minus 1, 2 minus 2, and again, it gives us a 0. Everything times 0 is 0. And that's the correct answer as I showed you before. Then you see 0, 0, 1, 0, and 2, 0. And we've done it. Now question B, they simply want us to expand those brackets. So let's do this. Function of x equals x, x minus 1, x minus 2. Now we can multiply in the x first and then multiply the two brackets. There's many ways of doing this. I'm just going to first expand the double bracket. So x times x is x squared. X times minus 2x is minus 2x. Minus 1 times x is minus 1x or minus x. Minus 1 times minus 2 is plus 2. Very common mistake to put a minus there. Let's simplify that. X, so x squared minus 2x minus another 1x is minus 3x. We're just subtracting. And then now we can multiply in the x. So x times x squared is x cubed. X times minus 3x is minus 3x squared. And x times 2 is plus 2x. Question 9c, it says find the coordinates of the turning points of the graph. Show all your working and give your answer correct to 1 decimal place. Interesting, that 1 decimal place. Let's look at the graph, what this looks like. All right, so the turning points will be there and there. See, there's the answers. So first thing to remember here is that if we do a tangent to the turning points, right, so here on the blue line is a tangent to the first turning point or the maximum point. That's the blue line. And then the green line will be another tangent to the turning point. And what do we notice about these tangents is they're perfectly horizontal. So that means the gradient is 0. Now if we want to find the gradient of any point on that curve any tangent on that curve, we need to differentiate. So that's the first thing we're going to do, differentiate. Okay, so we need to take the function of x, fx, and differentiate. So wait, let me first write down the function of x. And now we differentiate that. So remember, 3 times 1 is 3. Subtract 1 from up there, that gives me square. 2 times minus 3 is minus 6. Subtract 1 from the 2, that gives me just x to the power of 1. Or you don't have to put anything there. And the last one, imagine there's a 1. 1 times 2 is 2. Subtract 1 from that one, it gives us x to the power of 0. Anything to the power of 0 is 1. 1 times 2 is 2. So we can just let that x drop away. Okay. This is equal to 0 because the gradient at the turning points are 0. So that is equal to 0. And now we need to solve this. The fact that they told us to write the answer correct to 1 decimal place tells me that this is going to be impossible to factorize. So to solve this, we're going to use the quadratic formula. So let's do that. Okay, so remember, in this equation, a equals 3, b equals minus 6, and c equals 2. Quadratic formula is x equals minus b plus minus b squared minus 4ac over 2a. So let's substitute in those values. First, use brackets as much as possible. B is negative 6. Negative 6 squared minus 4a is 3. C is 2 over 2 over 3. Again, calculator. And let's put that into the calculator. So let's start with fraction. Negative 6. Let's start with positive value. Square root in brackets negative 6 squared minus 4, 3, 2, down arrow, 2 times 3. And we get our first value there. X equals 1.5773, etc. So here we go. This is 1.57. They say give your answers correct to 1 decimal place. Read the question carefully. That's 1.6. Right. To keep things accurate, we can also write over here the third form. Okay. Now, to find the negative value, we can just go back and change that plus to a minus. And we have the other value. X equals 0.422. 1 decimal place, 0.4. Okay, now of course we need the x value. To do that, we need to substitute back into the original equation. So we need to put these values up into our original equation there to get the right answer. Try to be as accurate as possible, so don't round it too much. Okay, 4 significant figures is always a good. The first one here, we need to go to y equals 1.577 cubed minus 3 times 1.577 squared minus 2, 1.577. So let's do that. 1.577 cubed minus 3, 1.577 squared. You got it right, minus 0.384, etc. Rounded to 1 decimal place is minus 0.4. And then we do the other x value, y equals 0.4226 cubed minus 3, 0.4226 squared minus 2, 0.4226. Put it into the calculator, 0.4226 cubed minus 3, 0.4. Again, make sure you put all the minuses and pluses in the right place. We get 0.3849 rounded to 1 decimal place, 0.4, and you got a good 8 marks out of that. Well done. Question 9D, it tells us to sketch y equals the function of x. So if you've been struggling with the previous questions and you can just draw a basic cubic graph, you already got 1 out of 2 there. Okay, but since we're getting everything right, we need to look at the information we have. First of all, we know where they are crossing the x-axis at 0, 1, and 2. So on the x-axis, we're going to cross it at 0, 1, and 2. Then we know the turning points. We know the 0.4, 0.4, so they're both positive. And the other one is 1.6 and minus 0.4, so that's going to be in the fourth quadrant over there. So in general, it's going to be a graph like this. Okay, now it doesn't tell us to show where it crosses the x and y axis, so this is fine. If we got the right crossing points and the minimum and the maximum in the right quadrants, you get your full marks. Question 10, Sarah, she's spinning a 4-sided spinner. Let's have a little sketch. What does a 4-sided spinner look like? It's like a spinner, usually circular, and it's got 4 sides, and in there it's got a 0, a 1, a 1, and a 3. That's it. What number is a spinner most likely to land on? Of course, that's just 1. There's 2 of them. So 1, that's easy. Sarah spins the spinner twice. Find the probability that it lands on the number 1 both times. So landing on the number 1, there's 2 of them, and there is 4 possible outcomes. So it's a half, basically. And when we spin it twice, it means that needs to happen twice. And this and that, when we do the and, it's the and rule, we multiply. So we multiply it together. Half times a half. Well, this will be 4 out of 16, or half times half is a quarter. So that's a quarter. Right, next question. Many candidates left this blank. Sarah spins the spinner until it lands on the number 3. The probability that this happens on the nth spin is that insane fraction there. Okay, find the value of n. So let's think carefully, right? She spins the spinner until it lands on number 3. So first of all, the probability not landing on 3 is 3 out of 4. Okay. So she spins it, it doesn't land on 3. The probability of that happening is 3 out of 4. Then she spins again. Let's say it doesn't land on 3. So that's another 3 out of 4. And she keeps doing that until, we don't know how long, until eventually it lands on a 3. And probably getting a 3 is a 1 out of 4. And if we multiply all of that together, we get the answer, 729 over 16,384. Okay, now the number of spins is this, yeah, that's the first spin, second spin, third spin, and then we don't know how many spins she goes on with, and then this will be the nth spin, the last one. Okay, now what's a different way of writing this? Would be to write it as a power. So we get 3 over 4 to the power of something times a quarter. Okay, what are we going to put up there? What are we going to put up there? There's a number. That number tells us how many times we got not a 3. And then, of course, there's this one, which is the one that we got 3. Okay, so that's the number we need to find. Now, the best way to do this, trial and error. I think that will be the quickest without breaking our heads. Okay, So calculator, let's pick a number. So let's start. We go fraction 3 over 4, close bracket, there. Think of a number. Let's try 5. Let's try 5 times 1 over 4. We get 243 over 4096. So 5 didn't work. Let's go a bit bigger. Let's try 6. Oh, we get 16,000. Yeah, we got it. 6. There we go. So this number here is 6. Okay. Is that our answer? Is n equals 6? No, because then there was one more spin here. So it's 6 plus 1. The answer is 7. Okay. Difficult question. Like I said, lots of participants did not even attempt this one. But you can do it if you practice. Question B, Scott. Hello, Scott. Takes an examination. The examination is in 2 parts, theory and practical. Both parts must be passed to pass the examination. Now, this is one of those questions where the best thing is to do is do a stem and leaf a tree diagram. Okay, so think about it. There's 2 tests. There's the theory test. We'll make that a T. And there's the practical. We'll make that a B. So first thing, the theory test. 2 things can happen. Okay. Scott can pass or he cannot pass. Probability that he passed, 0.9. Meaning having had to add up to 1 means that the not passed is 0.2. Then there is the practical test. And again, he can pass or not. Or if he didn't pass that, he can still pass the practical or not. Probability of passing the practical, 0.8. So not passing, 0.2. Right, so the first one says, what is the probability he passes the exam? So he needs to pass both, of course. So we're going to have to follow this path. Pass, pass. When we move along a tree diagram, both things have to happen, the 0.8 and the 0.9 and the 0.8. So we need to multiply it together. And that will give us a probability of 0.72. Of course. Okay, next question. What's happening now? Scott passes the theory test or the practical test, but not both. So what is the pathways we can follow here? He passes the theory test, but then he fails the practical test. So this is one possible pathway we can take. So that will be 0.9 times 0.2 equals 0.18. But he can also fail the theory, but then he passes the practical. That path gives us 0.1 times 0.8, which gives us 0.08. So there are 2 things that can happen. The pass, not pass, or the not pass, the pass. The one or the other. And when we got the or rule and probability, we add. So it would be 0.18 plus 0.08 gives us the answer 0.26. Question 11, let's have some fun with functions. First is the function of h. So let's see what the function of h is 4 to the power of x, but they have now changed the x for a 3. So that means it's power to 3. 4 cubed equals 64. Next one, let's write down the function of f. That's 2x minus 1. Then into that function, we put the function of h. So instead of x, we now put 4 to the power of x. And then, of course, as well, they've changed the x for a 3. So we change that for a 3. Okay. So just hammer that into our calculator to, well, we know the next one. And there we go, 127. Then it tells us solve the equation, the function of g, the function of f equals 0. So let's write first the function of g is x squared plus 2x. That's the function of g. Let's write it down like that. Then inside that, we put the function of f. So where the x squared is, we now need to put f, which is 2x minus 1. So instead of x, we got 2x minus 1 squared. Then we got the 2, and instead of the x, again, 2x minus 1. Now we just need to play around with the algebra a little bit. So let's expand. Well, let's first write this. 2x minus 1 squared means 2x minus 1 times 2x minus 1. Okay. Now we can expand the brackets. 2x times 2x is 4x squared. 2x times minus 1 is minus 2x. Minus 1 times 2x is minus 2x. And minus 1 times minus 1 is plus 1. Over here, 2x times 2x is 4x. 2 times minus 1 is minus 2. Let's simplify that. We have 4x squared minus 2x is minus 4x. And then we add another 4x. That will give us 0. And then 1 minus 2 gives us minus 1. Now remember, this is all equal to 0. So let's put that equal to 0. Now we need to solve. Now we can factorize this as a complete square. We got a square number there, a minus and a 1. So completing the square means that we can write 4x squared minus 1 in two brackets, because it's quadratic. But we just square root that. Square root of 4 is 2, x minus 1, and the other one plus 1. Again, I'll put a link in the comment section if you forgot how to do this. Now we can split it up. 2x minus 1 equals 0. That means 2x equals 1. X equals a half. Got the one answer. And we do the same with the plus 1. That means 2x equals minus 1. X equals minus a half. Well done. You've done it. Next one is just a very weird way to ask us for the inverse of the function of f. Okay, we don't have p, the function of p. There's no function of p, but we have the function of f. There it is. So let's work out the inverse of that. So one way of doing it is setting it equal to y, and then make x the subject. So first we add the 1 on the other side, and then we divide it by 2. Okay. Right. So the inverse of the function of f is x plus 1 over 2. Now, this can become very long. So this is equal to p minus 1. Now, if you want to know what p is, we're going to have to take that and reverse it again. Comes down to, this is the answer. And we've done it. Last one. Okay, be careful here. It's not the function of the function. Right, over here is the one function times the other function. Now, the function of h, of course, was 4 to the power of x. This means multiply. Let's put the multiply in there. The function of j is 2 to the power of x equals 1 over square root 2. So we need to find x. X is an index. If we can get all the base numbers the same, then the indices, we will be able to solve it. So first of all, we know that 4 equals 2 squared. So we can change this 4 for a 2 squared. There's an x already, so don't leave it out. We leave it where it is. Okay. Then square root 2 is the same as 2 to the power of half. Laws of indices. Also, anything that is a denominator can be written as a negative, meaning we can write 1 over square root 2 as 2 to the power of minus a half. And that's what we're going to do. Okay, if you're not sure, check it on your calculator. Type in 1 divided by square root 2, square root 2 over 2, 0.707. And type in 2 to the power of negative 1 over 2, and we get the same answer, 0.707. So we know it's the same. Now, because all the base numbers, oh wait, we're not there yet, we can now add these two together. When we multiply with indices, we can add the indices. So 2 to the power of 2x times 2 to the power of x is same as 2 to the power of 2x plus x, which is 2 to the power of 3x. Base numbers are the same, so we know 3x equals minus a half. So the next thing to do is to divide that 3. Okay, if you're unsure what that could possibly be, just hammer it into your calculator and we get the answer minus 1/6, which is correct. And you've done it. Well done. Thank you for watching. Hope you found it useful. Please like and subscribe. Leave some comments. See you again soon.